So this was the slide from where we have to start. Previously, we ended this topic of entropy. And now the information gain. We already went through this slide already. We got the idea that what this picture is giving us this idea that, for example, 5 positive classes, 5 negative classes, and here 5 positive classes, 5 negative mix. And when you have the mixed data, then here the title is you have low information gain for this data set. And similarly, on the other side, if you have 8 positive classes and 2 evidences of uh, negative class, and similarly here 8 evidences for the negative class and 2 for the positive, then here you have the high information gain. The, then from these pictures, we can get this idea that if the classes are separated properly, then you will get definitely the information gain high. Okay. So from this picture, we can get this idea only. So, but we will use this information gain for what purpose? To find the best feature from the data set as a split point, you can also use it for at the root, and then after the root, on the decision nodes, you can also use it for splitting on the decision nodes, uh, similarly like root node. And this information gain will use again the entropy. And entropy we already have seen previously, and the formula for the entropy is just pi log pi. So pi is the probability, huh? It is something, a probability value. And then we have the sigma and the negative sign outside. And now, so this ID3, which is mentioned here, ID is iterative dichotomizer. So this ID3 algorithm, we said in the beginning that we will study 3 different algorithms, maybe on some slide here. I said that we will study this ID3, C4.5, and CART, and this is read it by yourself. This is what I said, huh? So now we are going to see the ID3, the first one, and this ID3 will use which measure for selection of attribute. It will use this information gain that we are going to see. This information, this algorithm ID3 will normally use information gain IG. And what is the equation? Information gain is equal to entropy before, which means entropy of the parent, minus sigma j is equal to 1 to k entropy j. Entropy of jth class are these would be the children of this parent class. If this would be parent, then these would be the children. And these children can be more than one. So that's why you have the sigma here, huh? And for the whole tree. So this is a little bit complicated form of this equation. And then in the next slide, this form of this equation is written or represented again on this slide. And if you will read it, you will understand it quite easily. So information gain is what? You have to calculate the entropy of the parent. We already know how we can calculate the entropy of the parent from previous lecture. And then you have to subtract weights average. So you have to calculate some average of the weights here. And then you have to calculate the entropy of the children. So these two things you have to multiply with each other. And after subtracting it from the parent, then you can get the information gain from. This is what this equation is saying, nothing else. So now here we are taking an example. We have not done this example yet, huh? In the previous lecture. I'm asking you. So I am on the right side, huh? So this is the example now. And we will do this example to understand this information gain. And this example is saying that consider, I'm now reading this question. Consider an example where we are building a decision tree. We want to build a decision tree, huh? To predict whether a loan given to a person would result in write-off or not. I think I don't know. Maybe I'm feeling that I have done with this slide with your class. I don't know. Okay. So now we have to build a decision tree, and the purpose of that tree is to we will have different persons in the data set. In the data set, we will have, you can see this picture, or I will explain it later on. So in the data set, you have the data of persons, and then you want to see that what are the persons are who the loan of them is write off and the loan of them is not write off. So you will try to decide this thing from the data. And then in this data set, the whole population will consist of 30 instances. Or you can say 30 persons, huh? And then 16 will belong to the category of write-off, who have given their loan back to the bank, huh? So that is what write-off means, huh? And there are other 14 people who lies in the category of non-write-off class. Okay. Then we have two features in this data set. So the first feature is balance. This is the name of the column. And this column contains two type of values. One is the balance can be the salary or whatever the balance of the account. Huh? It can be less than 56K, 50K, less than 50K amount, or greater than or equal to 50K, that amount which is in the values of that column. And this is the feature, huh? This is the feature or the column. And then we have another column, residents, that can take on three values. And what are the values for this residence? The residence is the own residence or rented residence or some other category. Okay, these are the three possibilities for that. So now if we will draw this here, so the entire population is consisting, it is visible? Hmm? So 30 instances, according to this information, we are drawing this 30 instances, and 16 are write-off, 14 are not write-off. So, and here the probability of these two instances are also calculated, but leave it aside. You will calculate this probability when you will start calculating the information gain. So here, but if you want to see that, then it is very much easy. Total is 30. So 16 by 30, you will have the 0.53 probability for the blue. And similarly for 14, whatever you want to do, do it. I'm going on. So you should have to take care of this salah first. All the students who come here, then they ask for permission. You don't need to ask permission for the salah. Huh? This is something for Allah Almighty. Yeah. You have to do it first. Why all the students, when they arrive here and then they ask, I want to go there. Okay, you want to go there. So this is then 14 by 30, and this value 0.46 is the probability value for this class of stars. And these stars and blues are representing persons, huh? And then there are two categories, balance and residence. Balance less than 56, 50s K. So then the distribution is what? 12 and 13. Suppose if it is 12 and 13, then if you will calculate the probability, total is 13. So 12 by 13, you have this probability. 1 over 13, you have this probability. It's easy. And balance greater than or equal to 50. So after the distribution, blues are 4, stars are 13. When you will divide, total is 17. So just calculate 4 by 17, this probability. And now, how we will calculate the information gain? The question is, this is just information. This is the question. Huh? This is the question with the text and the diagram. This is the question. Now we have to calculate, we have to find, this diagram is not complete, but anyhow, now we have to calculate the information gain for these two features, balance and residence. And we have to find which is the best among these two, which we have to select for further, which we have to select. Our route is the training data. That that is this is our root, huh? And now we want to split, or why we want to select the best feature, and we can select this through this information gain. Okay, now we are going towards that. So first thing, we know the formula of this. Information gain is equal to entropy of the parent and entropy of the children. We have to calculate these two things first. And then this weight average would be like probability that you are seeing here, huh? That you are seeing here. Okay. You can calculate it easily by looking over this information, the weight average. So you need this entropy of the parent and children. Okay, then we are going to calculate the entropy of the parent first. So entropy of the parent first here, 16 by 40, 30. So 16. So for the blues, we have how many classes we have? Two here, two values, two types of classes. So for the blues, here I am for this node 16 by 30, you are seeing that probability here. 16 by 30 log 16 by 30. This is the equation for the entropy. This is the equation for the entropy. And the sigma is also there, which means you have to sum up all the classes, huh? So this is the class 1, and then this is the class 2, minus 14 over 13 log 14 over 13. And when you will calculate, you will get this one result. So this is the entropy of the parent. So you have one thing done for this equation, which is this one. And now you have to calculate the entropy of the children. And what are children? Children are these features, balance and residence. And from this, you have to select which is the best one, huh? So for that, we have to go to find the entropy of the children. And here it is, entropy of the balance when the balance is less than 50K. And this information is given in the question. When it is less than 50K, it is given less than and greater than. And what is the distribution? That is also given here in this picture. So then what? This picture is repeated here. When the balance is less than 50K, this node. And here you have blues 12 star 1. Entropy. Pi log pi, yeah? Pi is the probability. Total is 13. So 12 by 13 is the probability for the blues. 1 over 13 is the probability for star. Just write them in the entropy equation. 12 by 13 log 12 by 13. This is the first class. And the second class is what? Star. Then 1 over 13 log 1 over 13 second class. Calculate it and you will get this value. This is for the children. Balance less than K. And when the balance greater than K, entropy for that, okay, focus on that. 4, 13, 17 total given. So for blues, 4 stars 13. So 4 by 17 log 4 by 17 minus 13 by 17 log 13 by 17. So this is the first class, this is the second. And we are calculating entropy for the children. When you will calculate, you will get this value. So entropy for the children for this picture is now done. Is now done. What is left? According to the equation. According to the equation, weights average is left. According to this equation, the weighted average is left. So now how we can calculate the weighted average? Let's look over it. The weighted average would be equal to entropy of the balance without less than, without greater than or equal, okay? Both the children, huh? Entropy of the both the children with respect to this, with respect to this, with respect to the parent. So that's why we are here. This is the total 12 by 1 is total 13. This 13 is out of this 30. If out of this 30, so that 13 is divided by 30. And then this entropy we already calculated here. So we are multiplying it. And this is for the class 1. And similarly, 17. This is the total 17. 4 by, 4 plus 30. 17. And this 17 is from this 30. So 17 by 30. And this value we already calculated. So calculate it, evaluate it, and you will get this value for entropy of the balance, which is what? The weighted average of entropy for each node, Now the things are ready. Put or plug them into the equation. The equation is what? IG of the parent, information gain of the parent with respect to balance is entropy of the parent and entropy of the balance. This is the short version, huh? Short version of that equation. This is the short version of that equation. But some student can do a mistake here. Weighted average is there, okay? Don't forget, and don't only calculate entropy and then put the value there and give me the, you can give me the result. No, it's not. Weighted average is calculated here. Entropies are calculated, entropies of the children separately are calculated here. So now put the value of entropy of the parent. We already calculated it here, this 0.99. Putting the value here and entropy of the balance this 0.62, and we are getting 0.73 for what? For information gain with respect to balance. Information gain of this parent with respect to balance. We have this 0.37. Now, there is, this question is not complete yet. There is another possibility, and that is what this data set can be distributed to residents. Residence is the other feature which is given in the question. So that residence has three categories: own, rent, and other. And their distribution is also here: 7 and 1, 4 and 6, 5 and 7. Is it visible? Hmm? I can make it bigger like that, but then my pen will not work. Okay. So that's why I'm asking you. Okay. I am asking you. It is easy for me, but then my pen will not work. Okay. So where is my pen? Yes. So these are now, so residence feature, and this is the distribution 4, 6, 5, 6, and something like that. You can calculate the probabilities easily. Total is 8. So 7 by 8 is 0.8. And then this 1 by 8 is 0.12. I think you all are understanding, huh? It's not that difficult. So, and then here 4, 6, 10, 4 divided by 10. So you calculated the values for that. And similarly, you are calculating the values for that. Okay, now we have to calculate information gain. We already calculated information gain for the balance, and now we can calculate the information gain for this residence. Same procedure, same procedure. Nothing, no anything is different. So that's why here you can see entropy of the residence. We are calculating it. I'm not repeating it. Okay, you can, the same procedure. So entropy of the residence with respect to rent here. This is rent, huh? And this is 4. Total is 10. So 4 by 10, log 4 by 10. This is the first class. And then 6 by 10. This star is the second class. 6 by 10, 6 by 10. And when you will calculate it, you will get this value. Similarly, for other, you will get this value. And weights, how you can find the average weight? Entropy of the residence. Entropy of the residence. This total is 8. This total is 30. So 8 by 30. And this value you are getting from here. Similarly, for this one, total is 10. And this one is 30. The parent is 30. And the value for it is 0.7. And similarly for the last, calculate it and you will get this value. Put it in the equation, and entropy of the parent is already calculated. So put these values and you will get 0.13 for the as a information gain for the parent with respect to residence. Now, what this values are giving you the information? These values are giving you the information that you have to select that attribute or that feature which will have the high information gain. So this residence has low information gain 0.13 as compared to this one, which is the balance, which has a 3.7, which has the value 3.7. So you have to select what? You have to select then this balance because it has the high information gain. From these two available features, you will select what? Balance, because it has the higher value for your split. So this is how you can calculate the information gain. I have also mentioned here the balance. It is with the more higher information with this value is more informative as compared to the other one. So you can select this balance as a split point for the data set. Now the gain ratio. The purpose of the gain ratio is again the same. You will use this metric or measure to select the split point for the data. The purpose for which you are using the information gain, the same purpose you have for the gain ratio. We have the purpose is same, but our in the previous measure, which is information gain, that has the biasness. That has the biasness. What is that biasness? If you have more number of, if some attribute will have many outcomes in the feature in the column, then information gain will give high value to that column. Okay, if in the data set you have some feature and that feature has many rows, or you can say many values in it, then information gain will give higher value to that column. So that is the biasness. So this biasness is not uh, available here in this gain ratio, because this metric or measure, sorry, so this measure is overcoming this biasness. So this gain ratio is a better measure than the previous one, and it will do what? It will normalize the information gain by the split info. What it means? Here, if you will see the formula, gain ratio is equal to information gain divided by split info. So whatever information so this information gain is the same. This information is gain is what? It is the same, but we are dividing it with split info. When you are dividing, you are normalizing. Something like average. If has the higher value, you are dividing it and you are normalizing it. So anyhow, now we have another algorithm C4.5. This is what, according to that previous slide, I said that after ID3, C4.5 and CART. So now C4.5. So this algorithm uses gain ratio. C4.5 will do the thing. The algorithm is same like this ID3 algorithm, the steps. How you can build a tree, just like normal tree. Root first, then finding the decision node, then find the decision node and go on up to the leaf node. This is the general algorithm for every technique, but the selection technique is different. Huh? So, anyhow, so for ID3, we used information gain. And now here for algorithm 4.5, now here we will use what? Gain ratio. That algorithm is using gain ratio, not purely information gain. This is the formula. Information gain has the same equation as before. Split info is something extra. Something extra. What this is saying? It is saying sigma j is equal to 1 to k wj log base 2 wj. And what is this wj is here? And both. So one thing is sure, that it is the probability. It is like your equation of entropy, nothing else. If you remember the equation of the entropy, look over here, pi log bi sigma 1 to n negative symbol, and then here pi log pi sigma 1 to n, but negative symbol is not there. But equation is very much similar to that thing. And here we are calling it split info. So we will calculate the things very much similar to entropy, but here the name is split info. And this wj is what? It is the probability. It is the probability of each outcome that is available in that feature. That is of each outcome that is available in that attribute or feature. Same thing. Now, what is the problem with this IG? By the way, I have read it by yourself. This is theoretical. This is not something different. What it is saying, I can just give you an idea that if you have a data set and in that data set you have two features, color and size, and you have to build a decision tree for predicting the type of the fruit. Type of the fruit can be name of the fruit or whatever, apple, orange, or whatever. And if the color has three outcomes, which means if the color feature has three type of values, red, green, yellow, and the size has two type of values, small and large. And suppose if you are using IG method, then it can give you the color method as a best feature for selection so that you can build the decision tree. But suppose that this is wrong, okay? This is why? Because here you have more values and here you have less values. I told you that IG is biased, huh? IG is biased. Where in the column it has more values, it give higher information gain to that feature. And that is the reason here. That is the reason here that the IG method will give you this color as a best feature, not the size. And it can happen that size would be your actual best feature as a best feature for the prediction of your classes. So this is the problem with the information gain. So you can read it by yourself. And now we are moving towards the example of gain ratio. But this example is short example, giving you the idea about the structure of the problem, or you can say giving you an idea about how you can calculate the gain ratio for some given example. What are the steps involved in it? This example will give you the idea. So this example is not containing full calculation, but it's easy. So what is the question? Question is here. Let's consider a toy data set. This is toy data set with three attributes: temperature, humidity, and wind. And this play tennis is the target class. Okay. And this is the target class. Target class means from the model, we want to predict this. Either we should have to play tennis or not. And the conditions are given in the previous columns. And the conditions are given in the previous columns. Then the question is identify the best feature for split using GR. GR is this gain ratio. So identify the best feature from this data set for split in this next step using gain ratio. So you can only find this best feature if you know the formula for the gain ratio. And the formula for the gain ratio is information gain divided by split information, split info. And information gain is, entropy of parent minus weights average multiplied by entropy of children. So you can understand that how the calculation is going a little bit deep than the previous questions. So you can start from any point. You can start by first calculating information gain for each feature, or you can start by calculating the split info for each feature. So what you will do, you will calculate the information gain for each feature, whatever the feature. I have these features: temperature, humidity, wind. Similarly, I will calculate the split info for each feature. And when you have the information gain and the split info for each feature, then you will calculate the gain ratio for each feature. You will calculate the value for the gain ratio for each feature. And then you will compare these gain ratios values, and the feature which will have the higher value, you will select that for the split. Okay, now the things are, calculation is now only the size of the problem is now increased, but size still we have the same pattern of calculation. So first we are first calculating the split info for the temperature. Okay, then split info temperature. What is the equation? What is the equation for split info? Sigma pi log pi, something. And Yes, WRPI. I am just because I told you that it is like entropy, equation of entropy, huh? So and this Wj is the probability, pi Wj log w, whatever you want to say. So now split in for temperature for the temperature. How can so I'm just erasing. So now you have to think over it. You have to see the values of this. So total rows, total values are five, huh? In this column, how many values? One, two, three, four, five, huh? Out of five, two are hot, one is mild, two are cool. So three values in this feature, three values. Like in previous, you have resident three categories, huh? And now you have three. So you have to calculate the split info for this temperature for these three by considering these three categories. So then what? For hot, it is 2. So 2 divided by total 5 multiplied by log 2 by 5. That is for the hot. And then for the mild, 1 over 5 multiplied by log 1 over 5. This is for the second. And then cool, this is for the third, which is written here. Hmm? Clear? And then, okay, this is the minus symbol. This is the minus symbol, okay? This is the minus symbol. Okay, then multiply it and subtract it or sum it, and then you will finally get this value for the split info for the temperature. Now you have to calculate the split info for the humidity and the wind similarly. And here we have three highs, two normals. And for the wind, we have how many weeks? We have 3 weeks and two storms out of five. And then you put the value there and you will get the split info. Okay, we can find the split info for these two. I think it is available somewhere or not. Okay, not okay. Then imagine. Huh? You have to do it by yourself. You have to do it by yourself. Okay. And then formula for the gain ratio. Formula for the gain ratio is what? Information gain divided by split info. And here information gain from the previous question, information gain. And you know how to calculate information gain for these different features, how to calculate. So you will calculate the information gain by that previous, by this information, by this method, by using that method, you will calculate the information gain for each feature, the temperature, the humidity, the wind. And you also have the split info for these features, temperature, humidity, and wind. And now you will do what? You will find the gain ratio for temperature first. Then you will find the gain ratio for the humidity. And then you will find the gain ratio for the wind by using this formula, by using their respective values. And then finally, you have to compare these three values. And which one is higher, you have to select that. You have to select that for the split. And that would be the answer for this question. Highest gain ratio is considered as the best feature for splitting. Okay, this is mentioned here. Now, moving next. Gain ratio, another example. The previous example was not complete. Here, it is again incomplete. I will complete these, but rather you will complete these examples in the exam, huh? I will give you these incomplete questions, huh? In the exam, and you will complete this in the exam by taking your time. So, anyhow, example. So, first, this is the question here, and this is the last statement of the question. And here we have the data set, which is mentioned here. And in the data set, we have these features: fruit, color, shape, weight, biten. Fruit is what? It is the name of the fruit, which is mentioned here. Color is what? It has, sorry, this picture is coming in front of the text. Uh, okay. Now, And then this shape is what? The color has the red, the yellow, and the orange values. Shape is what? Round and the square values. Weight is what? Heavy, light, heavy, light, heavy, light. And button is what? Yes, no, yes, no, yes, no. This is also written here. The question is, the data set is given to you with this information. Find the best feature for splitting using gain ratio from these features. Find the best feature. And the target class is what? The target class is button. Target class is what? Button. Okay, here we in step 1 we are calculating the initial entropy of the target, because the parent class is given, button is given. So that's why we are going to first, whenever the target class is given in the question, that would be your parent class for the starting. So here that parent class is button. So you have, so for calculating the gain ratio, it is information gain divided by split info. Information gain is the containing the entropy of the parent minus weight average multiplied by entropy of children. So you have to calculate entropy of the parent first. That is needed. So that's why here we are calculating the entropy of the parent, which is button class, this class. And how many rows we have? 10. And how many yeses we have here? Maybe 5. 5 or what? No, these are not 11. It is one is starting from the columns. You are sleeping, so that's why you don't know. Half of the class is sleeping. And if I will do, maybe I will skip 5 slides and then you will wake up. Okay. You don't know. You know what is happening here, huh? You don't know what is happening here, huh? Act. I don't have the time. Otherwise, some story is coming into my mind which I want to tell you, but leave it, huh? Okay. So 4 yeses and 6 nos, huh? And entropy, this is the equation just rewritten, but we already know this equation. This equation is written according to this yes and no, but we know that it is pi log pi, nothing else. And we have the sigma entropy. So this is minus is that due to that entropy, and we have to find, so this is pi, probability of yes, log pi, probability of yes. And similarly, the second class, probability of no, log probability of no. Same equation. And here for the yes, 4 divided by 10, log 4 divided by 10, 6 divided by 10 for the no, log 6 divided by 10. When you will calculate, you will get this value. You will get this value. This is the entropy of the parent now, and parent is button, huh? Entropy of the parent. Okay, entropy of the parent is done. Now, either you can calculate the entropy of the children, and then so entropy of the children. Here we are repeating the equation for the information gain, nothing else. We are just repeating with some different words, huh? And here we will calculate this information gain, because this entropy of the parent is also needed for the information gain, but we are repeating it here. It's up to you. You can use the previous equation or you can rephrase your equations according to your question, huh? Here I am using yes and no, so that's why equation is rephrased. Equation is same. Anyhow, what is the equation of the IG? Information gain of some feature would be entropy of the parent minus weighted average multiplied by entropy of children. That second portion you can also write like that, weighted average of entropy of children, huh? Or you can write weighted average multiplied by entropy of the children. So that is the same equation, okay? That is not a different equation. That is not a different equation, same equation. And how we will calculate this entropy weighted average? We know that if you remember that blues and stars example, then children total divided by the 30, yeah, divided by 30. So that is that equation, nothing else. Weighted average of entropy of the children, that would be what? Probability of the children from the total data set. Child from the parent. And then entropy of the child, that you will calculate already. You will multiply them. This is that portion, nothing else. And you will calculate it for the first class, and then second class, then third class. So that's why sum is there. So this is not a different equation. This is the same equation, nothing else. Okay. But written in a different way by using different words. So, okay, just keep this equation aside because we don't want to go back to see the equation of information gain. And now for the gain ratio, we know that it is information gain divided by split info. And for information gain, we need the entropy of the parent, that is calculated. And now we have to calculate information gain for each feature of this database. For each feature of this database, if we want to consider all features. And here in this example, we are not considering this one, okay? We are considering only 3 features: color, shape, and weight, according to the question, okay? According to the questions. So now for each feature, shape, color, shape, and weight, actually, if you will download these slides from the Blackboard, then you will have 1, 2, 3 written here. I modified the slides, okay, so that it will be more understandable. It will not make you confused. Huh? So now for each feature, so we are not considering this feature in the question, but it is a feature. So color, shape, and weight. Now we will calculate information gain for each of these features, because the gain ratio has the equation Ig divided by split info. So first we are calculating Ig. When we will be done with that, then we will calculate split info. We will divide and we will get our answer for each feature. So now for each feature, these are the each feature, we are going to calculate the Ig. And for information gain, entropy of the parent is we have. Entropy of the children is remaining. So that's why we are going to calculate the entropy of the children. And the entropy of the children for this feature color. This is the first feature, and its children are red, yellow, and orange. Three values under this feature. If this feature is a node, under it, you have three values. So that's why we are going to calculate the entropy of the red, and I have given it the color green, and this has the color green, which means we are going to calculate this part. Huh? We are going to calculate this part. This part from that equation. Okay, moving next. We have, and for this, we have to calculate the entropy of the red. And if we have to calculate the entropy of the red, we have to first calculate the probability. Entropy means pi log pi. So we need probability, huh? So we have to calculate the probability of the target variable Byton with respect to this S, with respect to this red, okay? What it means? It means this is the red class, and how many yeses for you have for that, and how many no's, huh? You don't have to look on other entries. You only have to focus on the red and the Byton class. So here, probability of yes given red, if red class is given, what probability of yes is what? 1, 1. So 1 over 2.5. And similarly for no, 0.5. Probabilities are now we have. Pi log pi. Huh? We have now pi. And now we can calculate the entropy of the red. And the formula for that is what? Entropy of the red is what? We are just probability of yes given red log. This is pi. Same thing. We are writing this same thing. First class and then the second class. Formula. We are writing the formula. We have these values there. We are putting these values into it. Both have 0.5. So, okay, 0.5 for both the classes. Calculate it and you will have the value. Entropy for this red is 1. Entropy for this red child is 1 for the feature color. Now, similarly, you have to calculate for the yellow and the orange. So, and here shortly it is written entropy of the yellow is what? If you will focus over it, yellow and the classes here 2 2. So 2 by 4 entropy again you have the 1 entropy of rain of orange. So orange and these, and for orange these are the values 1 yes and 3 no's, and you have this value. So now you have the entropy of red, yellow, and orange. You have the entropy. Now you have to calculate the probability with respect to its parent, and then you have to calculate the weights, huh? According to that. So now probability of the red is now I have changed this color. I have changed this color, which is giving you a hint that we are now calculating this part, red color, huh? For your easiness, I have introduced the colors for similarity. So now probability of red. What is the total number? Total, the color is the parent. The total entries are 10. And the red is what? 2 out of 10. So 2 out of 10 is 0.2. This is the probability value. Weight you can. Probability of yellow is what? Similarly, 4 by 10. Orange 4 by 10. Now you can finally calculate the weights. So this weight that you have here, written here, multiplied by its entropy value, which is this one. Multiply by this one. And similarly, now this value, 0.4, multiply by its value. And similarly for the last one, when you will finalize it, you will get this value 0.922. Now this is the entropy for what? Color. Yeah, for this is the entropy for the feature color now, not all the. Okay. So you have now concluded only one. I will give you this question so that you will abuse me, huh? And then I will be happy. Ana shaitan, ana shaitan. Huh? No, 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 I will not, inshallah. But this is easy, okay? It is too much calculation, and there is a lot of chance that you will do some mistake here, and then you will give me a chance to deduct your marks. Okay. Okay. Anyhow, this is an entertainment between a teacher and students. Okay. This is what we have only in this world. In this academic world, this is the thing we have only. Huh? So anyhow, so now information. So this is done. This is all the calculation that you have done is only for the color. So you have to execute, or you have to do the same calculation again for the shape and then for the weight. So now, up to now, we have calculated the entropy of the children, you can say red, yellow for the color. And now we can calculate the information gain for the color. And information gain for the parent, we already have 0.975 somewhere. We calculated here for the class Byton. And now this 1.992 we have calculated here. After subtraction, you have this value for the color. So now you have to calculate the information gain. This is the information gain for the color, and you have to calculate the information gain for the shape and the weight. Shape and the weight. You have to calculate it for the shape and the weight, and then all features will be finished. And then you will have the information gain for all the features, color, shape, and weight. And when you will calculate it, after that, the split info will start. You will calculate the split info for each feature. And when you will have, then you will divide. And then you will get final values for all the features. And then the last step, you will compare. The feature which will have the higher value, that is the feature that you have to select for splitting, yes. So now, step 3. So I have written here that you can calculate the information gain for shape and feature by yourself, okay? It's not difficult. And I have already calculated it for you on these pages, huh? This is the material is ready for your exam, huh? The material is ready for your exam. I will not share this document with you, huh? So that you can calculate it by yourself. You really have the numbers. Yeah, yeah. This is what, when I prepared this lecture, this is what I did first. Hmm? So anyhow, now up to this point, we have calculated the entropy of the parent, and then we have calculated the information gain for all the features, shape, weight, and color, up to this point. And now what is left? Split info is left. We have not done anything for the split info yet. So that's why we are going to calculate the split info for each feature. And we are starting with the color. And the equation would be what? Probability of child. So equation is again same. Equation is like entropy, huh? Pi log pi with the negative, huh? So, and if you have many classes, so that's why then you will have the sigma, huh? That's why you will have that sum representing that sigma. So probability of child log probability of child. This is the equation for the split info. For example, color. And color. And what are the children of the color? Red, yellow, orange. So now you have to see some. So split info color. And if you will see, you already calculated this value. And red is 2 times out of 10, huh? So you already calculated this value here, somewhere here, huh? You can use this information speedily. So this 0.2 means 2 times 2 out of 10, huh? And this is 2 out of 10. This is 4 out of 10, 4 out of 10, 4 out of 10, 4 out of 10. And when you will solve it, you will get this value for the color. And similarly, you can find the split info for shape and weight. Fill in the blanks. You have to fill it by yourself. Okay, so now information gain for all the features is done. Information gain for split info for all the features is done. And now you can use the gain ratio formula to calculate the gain ratio. And the formula for the gain ratio for each feature, here we know gain ratio is equal to information gain divided by split info. So now you have to calculate this gain ratio for each feature. And now we are going with the color. Gain ratio for color is equal to information gain of the color divided by split info of the color. And information gain of the color we already calculated here, 0.049. This is done. This is here. And divided by split info, 1.37, which we have calculated here. And when you will evaluate it, you will get this answer. Similarly, you can find the gain ratio for the shape and weight. Now you have the gain ratio for 3 different features. Now you only have to compare, and then you have to select what is the best. What is the best one, huh? And from that, shape, what are that? Shape, weight, and color. I think maybe the weight will be the best. If I am not forgetting. Weight is the best, okay. I will share this document with you. You can see I use the cam scanner after that. All the hard thing is for me, for you, all the things are already prepared, huh? You only have to make it ready. Anyhow, so now, where was I here? So now this gain ratio is done. And the algorithm which was, yes. For the parent column, usually they provide it in the question, or sometimes I need to calculate the parent column. No, I didn't understand what you're asking. The column here is fitted or not? Yeah. Here? Yes. I will give you all this information. If you are asking that does this information will be provided? Yes, this data set will be given to you. This whole lines will be given to you. This is a question, proper question. The data set, I will give you this table. What these columns are, okay, it is. For example, we are not considering fruit here. I will mention it here. You don't have to consider fruit, or maybe you don't have to consider something like that. How the parent, the adults, children, if you provide like you can say big. No, no, I will not provide you big tree. This big tree, you cannot decide. You have started from the root. On the root, you have all the features there with the target class. So you only have the target class and all the other data set. Where you have to go next, what features you have to select next, that is what you have to decide by this gain ratio. So I cannot give you the tree, okay? I cannot give you the answer. You have to find the answer mathematically by this gain ratio. Okay. Now, the last one, the Gini. The Gini index. Now, this is the third measure that we will use for the same purpose, for finding the split point. For finding the split point. And we have another algorithm that is called CART, which means classification and regression tree. So the sequence of the algorithm is like ID3 that you have seen, step this, step this, step this. But what is the selection technique? This Gini is the selection techniques there. This is only the difference, huh? So this Gini is the selection technique there. We use this technique to find the impurity of the data set. We can also use this for split point, okay. We can also use this measure to find the impurity of the data set. Purity of the data set and impurity of the data set, we already have seen these two terms in the previous lecture. Is there anybody who will tell me what is purity of the data set? This is the answer. Yes, Jabari. Purity of the data set, you have, for example, different types of data that are taken into consideration when you try to take, for example, pick from the data. You have different, a lot of data that is different from each other. Therefore, it's impure. You can't make a decision on whether the data is. Any other? Yes. Any other? Yeah. That data based on some feature. Sometimes there is some data from other features came. So the list, this data came into other the bits for the cut. It will be this pure, more pure. The more is become more impure. There is no overlapping in some. Partially okay, but these are not the right answers. Normally, when we say this data set is pure, it means that this data set will have clear categories. Okay, clear categories. Okay, and if your data set does not have clear classes or categories, then the data set is not pure. Simple. So anyhow, so the value of this Gini, the range of this Gini would be from 0 to 1. 0 means pure data and 1 means impure, okay? And then you can have in between, huh? I will go a little bit fast because time is also going. Let's see, not too fast, but let's see. So mathematically, now mathematically means the equation for this Gini. So the equation for this Gini is 1 minus sigma pi square. So this pi is your same old friend, huh? Probability of something, and you can say probability of class, huh? So, and that sigma, okay, if you have more than one classes, then we will use this sigma. And we will find the probability and we will take the square plus another class, and then finally we will subtract it from one. And now this formula, another form of this formula is this 1 minus sigma pi multiplied by 1 minus pi. And this whole thing is within these parentheses, within these big parentheses. And here, this pi is what? You know that it is the probability of a specific class. Summation, you know that from your previous. If you have more than one classes, then you will go on by using that summation. Okay. We have now get the understanding of Gini and its equation. And now the question is how to identify that data set if that data set is not pure. So for that, we are considering a data set, and that data set is containing two classes, yes and no. Yes, easy example to understand, huh? So suppose we have a data set with two classes, yes and no, and the probability of yes is 0.3, probability of no is 0.7. Now we can use the equation. So Gini equation, then 1 minus pi square, sigma pi square. So this is class 1. So we are taking 0.3 square, and then minus, this is class second. We are taking 0.7 square. After calculation, you will have this value. Similarly, when you will use the second form of that mathematical equation, 1 minus pi, which is the first class, multiplied by 1 minus pi. So this is, yes. Because, yeah, this is minus due to that entropy concept from where we started. From where we started. Here you have the minus also. If you will take plus, you will multiply where you are. Okay. Yeah, go to class 3 and 4 and come again. Huh? Take some lecture in this primary school and then come again. Huh? This is Ramadan actually. And if some person is feeling the soma, rosa, the fasting. So if you are feeling thirsty or something like that, then the connection with the brain is connecting, breaking again and again. Yeah, so this will happen, especially in this time. This is the toughest time after us. This is the toughest time. Huh? Anyhow, so 1 minus 0.3 multiplied by 1 minus 0.3. So this is according to that second equation. Pi multiplied by 1 minus pi. And this is for the first class, and now this is for the second class. After calculation, you are getting the same value. So that's why you can use any formula from it. It will give you the same value. So both these formulas are giving us this 0.5% chance that if you will give some input and you will find to get the class of it, it will give you the wrong class, misclassifying. And the chance is what? 45% for this, for this example. And we also know from the range that if the range is greater than 0, 0 is pure 100%. And if you have some positive value, then it means you have that percentage of impurity in the data set. Okay, moving next. How to find the split? How to find the split feature? How to find the best feature for the split? Again, we have this data set. We are considering this data set with age, gender, income, credit score, buy insurance. And this buyer's insurance is the target class. Is the target class with the yes, no values. And these are the features. So you can say that this person will buy the insurance or not. This person has age 20, gender male, income high, credit score excellent. It will buy the insurance policy or not. So this is what it means, huh? I will not explain this in the question that what this thing is going to say. You have to understand it by yourself from the data. Okay, you have to become now a little bit towards, you have to become scientist, how you can see the data and then you can understand what this data is talking with you. Your data is talking with you. Do you have those abilities to listen the talk of that data? Make yourself on that level. Okay. So so okay. Okay, we will discuss it later on. I don't have time. I don't have the time, huh? We will discuss it, inshallah. I skipped my story that was before, okay? And you are now giving me your stories, huh? So, anyhow, so now we have to calculate the Gini, which will calculate the impurity of this data set, or you can say the target class, which is bias insurance. So here we are simply using the equation Gini impurity 1 minus, okay, you can see the values here, 3 yeses, 3 no's, huh? And then 1 minus probability of yes square and probability of no square. This is written according to the equation, nothing else, huh? And then here probability of yes is 3 by 6.5, probability of no is 3 by 6.5, okay. Now we are putting in the equation, in this equation. And then 1 minus 0.5 square minus 0.5 square, you are getting this one. This is very much easy question, huh, among all that. But that gain ratio will give you a tough time. Okay. So now we have done the Gini impurity for the target class, but we have to find for the same thing for all the features. So now we want to calculate the Gini impurity for each feature, And then what would be the formula? Due to summation, this class, plus this class, plus this class, plus this class, up to n classes, huh? So Gini impurity will become what? 1, then the first class, then the second class, plus third class, and so on, plus last nth class and scale, huh? And then here we are calculating the Gini for the age. Age is the first feature. Age is the first feature here. And here all ages are different, 20, 25, 30, 35, 40, 45. I cannot count 2 or 3 or what. All are different. So anyhow, calculation is easy, 1 over 6. So probability of age with 20 is 1 over 6.17, with 25.17, with 30 and so on. Huh? Easy calculation. And now Gini impurity for the age is what? 1 for the first value, first child value, you can say second, third, fourth, fifth, all these values, and last one. And when you will calculate, it will give you 1. Okay, this is done with age. Gini impurity for the gender. Oh, I can remove my own face from here because the table is behind. Okay. Okay. Okay, now the gender, huh? Now the gender, male, female, male, female. So now you can count, and it is 3 by 3, huh? So probability of male 3 by 6.5, female 0.5, easy. Gini impurity would be 1, 0.5 square, 0.5, and this is the value. For income, this is also available in the data set. Here I have made that picture short so that I have a space on this slide. So then here count it, it is 3, 1 and 2. So 3 by 6, 1 by 6, 2 by 6, and you have their values. And the Gini impurity by using that equation is 0.44. And similarly for the credit score, which you like most, so probability for the excellent, okay, excellent 3, fair is 2, poor is 1. So 3 by 6, 2 by 6, 1 by 6, you have the values, put it in the equation and you have that value. So now you have values for the target class Python. And here, if you will see, the age has one value, which is higher, means class is impure, which means this feature is impure. And here the gender, which has 0.5, 50, and then 0.4, 0.4. So these two has, so now with the Gini, you have to go with what? With the lesser value. You have to go with what? With the lesser value, with the lower value. You have to find that feature which has the lower value. That will you will select for the split. And here you have these two. And if you have two features with the same value, then you can select any from them. Okay. Then you can select any from them and as a best feature for the split. Now, how to avoid overfitting in decision trees? So you know the definition of overfitting. Huh? On training good, on test fail. Huh? So this is like a person who is good at home but in the field zero. Huh? Yeah. Yeah, but in the field it like zero, huh? So how to avoid this overfitting? This is just now theory, okay? This is now like a news. You have to read it, and this is only information, additional information. So if your data set is full of features, full of columns, then it can cause overfitting, okay? It can cause overfitting. When there is no limit set on the decision trees, when there is no limit, you have to draw the each branch for each feature, for each value, and then your tree will be expanded, and without limit. You don't have the limit. Then it is possibility that for each value, for each observation, you will have one leaf node, huh? At the end. If there is no limit, that is the worst case, huh? And in this case, and if you have this thing, this will affect the accuracy of your model. And if you will give something as a test example, which is not the part of training, it will not give you the output for that. So how you can remove this overfitting? By two approaches. This is easy, okay? Pruning decision trees and random forest. No mathematics, okay? No mathematics, only theoretical idea. You already have, might be in your previous course, you already have studied this, how the pruning decision tree. Pruning means filtering decision trees. You have to remove some branches from the decision tree which are not needed. And random forest, okay, that is some model in which you will combine the decision trees into it and you will make a forest of trees. Okay, that's why it is a random forest. Anyhow, in pruning, you will start from bottom up, from leaf nodes to up, towards upward direction. You will do what? You will cut off or you will trim off some branches of the tree from the bottom, from the leaf nodes, you will start from the leaf nodes. And if after cutting those branches off, if the accuracy of your model is not disturbed, then okay, remove them. Then okay, remove them. And when you will do this, this is called pruning. This is called pruning. This whole method is stepwise written here, that this is called post pruning technique. Uh, and this technique will do what? It will allow the decision tree model. You have not done the pruning yet, okay? And if your model is running, it will do what? It will expand your tree up to the maximum depth. Up to the maximum depth, it will expand. And then what? After it, it will now you can, when you have the whole tree available, then you can start the pruning. And you can remove a node with its children, which means a branch, huh? Subtree, you can say. Then you can remove it. And after the evaluation, if the accuracy of the model is not disturbed by using some sample data, which you can call it validation set, huh? Validation set is normally you used during the development. Okay. And if the accuracy is not disturbed, okay, then remove that sub branch. This is again the same thing. So this is called pruning. And you will keep on repeating this pruning step with each node from bottom to up until the accuracy of the model is not disturbed. Until the accuracy of the model is not disturbed. This is a figuratively example, nothing else. Here, income, if it is greater than 30K, and if that person is taking other loan from the same bank, yes or no? If yes, if that person has loan from the same bank, other loans, if yes, give him more loan, huh? And if no, then documents are required. If the documents are submitted, give him loan. If not, no loan, huh? Similarly here, if the salary is less than 30K and have the criminal record, if it is yes, no loan, no, then documents are required. If the document submitted, loan, no, no loan. And here we are saying, okay, we started here, and after checking, some person has checked that this is not needed. This whole branch is not needed. Okay. Yeah, maybe you normally take interests in finance. Most of the time you discuss something like that. So that is something example related to your interest, huh? So here we started from here and we reached here, and then some programmer have found that this whole branch is not affecting the accuracy of the model, and then he deleted this whole sub branch from the tree, started from here to here, and then only this one, either salary is greater than or equal to 30, then these are the conditions. If salary is less than 30K, khali wali khalas, maafi, huh? So this is what the idea, figuratively idea. And similarly for random forest, what is random forest? This this model or this technique, random forest, you can use it for classification and regression, which means in uh, supervised learning, you can use it for classification or regression. And this random forest is a combination of some things. So that's why it is ensemble learning. You have heard the term ensemble learning. What is the definition of this ensemble learning? What is this ensemble learning? Ensemble learning is something in which you will ensemble different things into one model. Ensemble, and then that model will learn through those different things, and finally whatever the results of those different things, finally it will make the average of those results, or it will do some other thing with the by combining those results, which you can call it aggregating or something like whatever. But this word ensemble means ensembling, huh? You are combining, you are connecting, you are combining multiple. Here in this random forest, forest is with the trees, huh? So in this random forest, you are combining multiple decision trees to produce a more robust model. Robust normally means which will contain many things, diverse things, huh? And now that robust model, we are calling it random forest, huh? And from these different multiple decision trees, it will predict something, and you will finally get the average of those predictions, or you will apply some other formula which can give you some aggregated result of all those production. This is figuratively our pictorial description. We have the training data. First, we will divide it into subsets. First, we will divide it into subsets, and then we will make the subtrees, decision trees for each subset. And now you can imagine if you have n trees. Here, this is a small example giving you the idea. So now you have a collection of trees. So that's why due to this area is called random forest. And these decision trees will give you the prediction, will give you the decision. will give you the result, which you can average finally. And now, here, if you are using a bagging technique in this random forest, what you have to do, you will have these n samples, n trees, tree 1, tree 2, tree n. You will have the data set is divided into n samples. It's the same thing. Nothing is different. But now going up to n. So if you are using this bagging technique, that in this bag, you will do what? You will divide your data set into n samples using some random approach. And these n samples, you can say, okay, these are n samples are n trees. Then you will combine them, these entries, into a single model, into a single algorithm. You will combine them. You will, or you can say, you will create a single model, and then you will put all these n samples in it, like this, n samples in it. And whatever their predictions is, finally here you can see in this equation, we are summing up the predictions and then we are dividing it with the number of classes. It will give us the average result, nothing else. So this is theory. This is theory. This is the last slide, which is better, linear or the tree-based model. So if you have the models, from those models, which one is better, linear model or based model? So then you can say, what is the relationship between the dependent and independent variables? Dependent variable is the output, independent is the input variables. So if the relationship between them you can judge through a linear model, then you can say, then here linear regression will outperform the tree based models. Or you can say then logistic regression or linear regression, these type of models will perform better than tree based models. And if there is a high non-linearity or complex relationship between dependent and independent variables, then these tree models will outperform the others, outperform the linear models. And if you want to explain some model to the people, then logistic regression is not easy to explain. The CN tree model is easy to explain. Okay. So this is the source code. And if you will run it, this it is using some, I am not explaining, you can read it, you can run it by yourself. So we are downloading some data set directly from the internet, okay, because this is HTTP archive, okay, directly from internet. And then on, this is the information about that, what is length, shape, or whatever. And for that data set, then we are drawing the decision tree using Gini, and then we are drawing the decision tree using entropy, and then your model is all automatically splitting and finding the best feature and drawing the decision tree according to that. So you can run this source code by yourself. And okay, extra, this is extra, not needed. Confusion matrix calculated, accuracy calculated, and all other precision recall calculated, but not needed. Okay, that the first output is needed. Okay, this is for the for the first tree, and this is for the second tree, the results. What is the overall accuracy of the Gini and what is the overall of accuracy of the entropy. And this is the end.